Welcome everybody, this is the 3D Printer Chat podcast, the podcast about 3D printing, and I'm here today with a special guest. We've got Martin Bondéus from Bondtechs with us, an expert on all things extruders and extrusion and 3D printing with higher quality and faster speeds, I believe. How are you doing, Martin?
Very fine, Chris. Nice to be here.
It's good to speak to you. I've admired your extruders but never actually used them, so I'd like to find out all about them. How did you get into doing this? How did you get into 3D printing and manufacturing your own product for 3D printing?
I can give a short about my background. I've been working with production and product development for, I think it's 25 years now. And I have been really interested in technology and these things. And I started to work with 3D CAD, but that was mostly for making injection molds, designing injection molds for plastic. So I started with really 3D CAD, and I have really loved doing development work, both for production tools and also for products in 3D. So during this time, I also worked as a product developer. We started to use 3D printing to order prototypes for new products, to evaluate them and to use them as a good instrument in our product development. This was the first real contact to 3D printing, I would say, and this was sometime in the late 90s. But at that time, 3D printing was not accessible for normal people because the machines were really expensive. So since I've been really liking technology a lot and machines, CNC machines and everything, so when the first 3D printer kits were coming on the market, since I really love technology, so I said, okay, I must get one of these.
Yeah.
So that was in the end of 2012, I think it was. Then we bought the first machine. It was a kit. It was a Velleman K8200. I think the name is. Yeah. So that was the first machine, and it didn't work so great out of the box, or that was a kit, so we built the machine ourselves. But we had a lot of problems with it. We were producing really bad prints. So since I've been working with injection molds and plastic injection molding a lot, and I don't like things where they are not working good. Yeah. I want perfect surfaces. Everything could be perfect. That would be the best. But so that I started to rebuild that machine to make it better, trying to make it function better, and it. After Jules said upgrades and some other things, it started to work quite good. But then I said I wanted to have bigger parts. So I say, okay, I will design my own printer then to make it bigger. And there I also wanted to be able to print fast. And therefore I chose to go the route to use a Bowden extruder instead. And that was a Core XY. The motion platform was a Core XY. So I built a prototype of that one, and I did a lot of errors with the new development. So after some time, I got it to work quite good, but I had so much problem with the extrusion. So it was under extruding, it was grinding the filament, and I started really to. That was really annoying because you could leave a print, and after 4 hours, it started to grind the material, and you have to start all over again.
Yeah.
That is quite a common problem. And I tried quite many different extruders also, and I didn't have any great success with them. So therefore I started, okay, I need to solve this issue first. Otherwise I will not be able to have the printer working. So I started to think about how to make the extrusion more reliable and try to find a better solution.
Yeah, so, the big problem I've got right now on a printer is it's under extruding and grinding, and that's the Atherbot, and I think it's using a Mark 8 extruder. Yeah. And that's one of the things that it's very hard for beginners especially to solve that, right?
Yeah, it is. And also since there is a lot of talk about extruder calibration, you probably know it, to set exactly the correct E-steps for the material and these things. And the problem is that what I have found is that with normal extruder, it slips more or less. Yeah, that is quite common, and therefore you don't get a consistent calibration. Even if you set it, it still slips, so it doesn't get consistent results, and that has a direct effect on the surface quality of the parts.
Yeah, but also one of the solutions for under extrusion is to increase the temperature, and then you get more stringing, right?
Yeah. It's the whole 3D printing. It's quite a complex actually, because there are so many parameters included. You have the layer thickness, the polymer you are using, the temperature, the flow. You have the layer height, extrusion width, acceleration, printing speed, and all these things work together. So yeah, and can be quite hard to find the sweet spot where all the parameters match up and produce good results.
Yeah, and nobody wants to print slowly because the idea is rapid prototyping. You don't want to be waiting 3 days to find out you've printed your part wrong.
No, of course, that is an important factor. But as with everything, if you want really quality, you need to lower your speed, of course, because it's everything is related to speed. That is also with the normal machining and everything. So that is nothing. But as you say, you don't want to wait longer than you have to. And for sure, you don't want to restart the print after it has failed grinding.
Yeah. So how did you come up with your solution, which is it's a smart solution that nobody seems to have replicated? So how did you come up with that?
Actually, I have, since I've been working with product development and production and so many years, I've been learning a lot of how to produce things and how to machine things. So I have quite a good development knowledge, I can say, but also an understanding of how to produce parts. Because you can design something, but if you can't produce it effectively, you will not have a great success anyway.
Yeah.
So actually, I've started to working with the designs and trying to find standard parts that I could use to have the first prototype ready. And I was able to find parts that I could build the real first rough prototype. And it was many iterations later from where we are today, of course. But the first prototype worked really fantastic. It removed more or less all my problems I had before. Since the dual drive that we use today, we grip the filament from the both sides. That's the main difference. And that gives so high grip of the filament. So we move the whole window, because with normal extruders, the amount of force they can give reliable, that lies quite close to what is needed to push out the material through the nozzle. And therefore, a little disturbance in temperature or something like that, or the melt viscosity in the material or something, that could go over the limit where the extruder can push the material. And therefore, it's quite sensitive. With our extruders, we have moved that window much higher. So normally, you don't have any extrusion problems.
Yeah, so what can you actually achieve now with that extruder? What have you managed to do with that you can't do on a regular extruder? Like, is it worth me swapping out these Atherbot ones that are causing me problems?
I believe so, yes.
So you mentioned quality. How does it improve the quality of the output? Because I can understand how it improves the speed and the consistency, but how does it improve the quality?
If you have an MK8 type of extruder that is direct driven, then you have 90 as a E-step value. That is with 16-bit microstep, and that almost everybody uses. We have our QR series. There we are using a planetary gearbox that gives a reduction of 5.8 into 1. So that makes the E-step value is 476 for the 1.75 version. that gives a higher resolution. So the extruding of the material is more exact.
Right.
You have 4 times the resolution, more or less.
So it's a precision thing rather than...
yeah. Precision and also the consistency, so it never slips on the filament. What you tell the extruder to feed, it feeds.
So you don't get the inconsistent layer wobble.
Exactly. And that is our QR series. We also have our BMG extruder that have been a great success for us. It's a cheaper version. It doesn't use the planetary gearbox in steel. It uses spur gears instead, and that is a cheaper solution. Still works very good, but it's cheaper to produce and it gives a cheaper solution. And that one we use as 415 as the E-step value.
So how easy is it to swap out these things? Is it like a direct replacement, or do you have to print off a carriage?
Well, it comes down to what printer you have. If you have a printer that is a Bowden printer, then it's just a matter of finding a mounting bracket to mount it normally on the back of the machine. So that is normally easy because you have a lot of space for the extruder. If it's a direct extruder, it gets a little bit more complicated because you have limitations on the existing printed design.
So like a CR10 or anything like that with a Bowden, it's just going to be a simple swap out?
More or less, yeah. The CR10 actually needs a small bracket because the extruder position is so very close to the Z axis screw, lead screw on the Z axis. So actually it needs a bracket to position the extruder a little bit from to the side. And then you need to also adjust, of course, the E-step value.
Yeah.
Yeah, and
you said that's 150.
For the BMG, it's 415.
Okay.
Yeah, 415. And depending on what printer and what software you are using, you can do it in some different ways. Cool. If you're using a Marlin, you can, of course, just put it in the configuration.h file in Marlin and put in the correct E-step and recompile it and just upload the new firmware. You can also send it by a G-code to the printer.
Yeah. There
is a setting in Marlin that allows you to send G-codes and also to save the configuration to the EEPROM. Cool. So you can send, if you can send the M92 E415, press enter, then it sets the E-steps value, and then if you can just send the M500, it will save the value to the controller. But on all printers, that is not activated in the software. So if you can't save it, you can also add it in the start section in your slicer, M92 E415.
Cool, sounds good. So tell me about your drive gear is going to be using the Prusa Mark III, right? Did I get that right?
Yes, that is correct. Actually, they started to use our gears with the multi-material kit.
Oh, cool. So you've been working with them for a little while now?
Yes, I think they started really in the start of 2017 to start working with them with the multi-material upgrade because they had some problems because our gears are very kind to the filament, you could say. So it doesn't deform the filament so much as normal extruders. And I think that is a really important feature in the multi-material kit since they pull up the filament out of the nozzle and pull in the new filament.
Yeah. And so retractions and...
Yes, of course.
So they're just using your gears, they're not using the extruder?
Yes, that is correct. They have... Yeah, I bet you have seen it. They have quite a huge print farm down in Prague where they are producing all parts. So we are just producing the gears for them.
Awesome. Well, what's next for you? Have you got anything in the pipeline? Anything coming up? Anything exciting that you're working on?
Yes, we have. Just to make a small teaser, I think it was in the weekend or something like that. We will release a new product hopefully this weekend or something like that.
Anything you can tell me about it, or do we just have to wait and see?
There are some images on Twitter and
Okay.
our Facebook page, but it's an upgrade for Ultimaker.
Nice. I just got an Ultimaker 3 to review, so I'll look out for that.
Yeah. We have upgrades today for Ultimaker 2 and Ultimaker 3 with our normal Bondtechs QR extruders. That is the one that is using the planetary gearbox.
Cool.
But it gets quite expensive. So we wanted to find a cheaper solution, also that is cheap, easier to install, and reuses the original stepper motor. So we have a new solution for that. It will be released hopefully this weekend.
Cool. Well, thank you very much for your time, and thank you for telling us all about your extruders. And maybe we can get you back on a future episode and talk more.
For sure, yes.
Awesome.
Thanks so much for having me.
Thank you, Martin, and thank you everybody for listening. Please do subscribe, share, like us, and look out for the next episode. Thanks, everybody.